Alright, boys. Let's do a daily today. Maximum number of operations to move ones to the end. Okay, we can perform the following operations on any string, any number of times. Choose an index I where from the string where I plus s dot length such that two adjacent elements were such that s of I and s of I plus 1 is a 1, 0. Move the characters of s of I to the right and until it reaches the end of the string or another one. For example, 0 1 1 0 1 0 0 1 0. If we choose an I, okay, this is kind of confusing. All right, let's see this. So we perform the following operation: I of 0. The resulting string is okay. Okay, so you just basically move. Oh, okay. You want to move. Okay. Okay, just basically, how many times can you move I? Okay. Move once to the end of the thing, okay. Okay, I see. Okay. Okay. Okay, so move, detect if s of I equals 1. Oops. Iterate through okay, so if s of I equals 1 and I plus 1 equals equals 0, right? So we detected this. So why do we basically swap with the first next 0? Okay, 0, okay. 0, 1, 2, 3, 4. And then what happens here? You swap those two. 0, 0, 1, 2, 3. Oh. Okay, first I need to convert this to, I think I need to, right? Because I'm going to do a lot of swapping. if you choose index 1, right, will be to the right until it reaches end of the string or another 1. Ah, I see, I see. Okay. So it's like some basic simulation here. Okay. I feel like this might be pretty slow. And then we continuously swap. Okay. Okay, I see. Basically, it's like a while true. Okay, this is gonna be tricky. I don't know when to stop, basically. Okay, I guess we could say if I less than length of, yeah. We'll do one of these. Well, if s of I and s of I plus 1, I'm gonna do one less, right? This f of I equals 1 equals 0. Swap, so s of I. Actually, I don't know where to swap, so we'll do a j here. J equals I, and j plus equals, right? While something is true, oh my goodness. Okay, so as a list of I plus 1. Okay, so no. Let me just think about this for a second. So I start here, basically, while j is less than length of s list, right? I don't want to go beyond. Yep. And increment this. Only if s of s list of j equals a 1. Oh, equals a 0. No. Basically, the next or 1. So basically, yeah, if you're that, I guess equals 1, then break, or you'll be will be terminated to the end of that. Then we'll do s of list of I, string list of j equals string list of string list of j and string list of I. Yeah. Right here, right? Swap. Find the next one or end of or place pointer to end of list. Okay, hold on, just give me a second. I do need to do this though. Okay, then we swap. Then I need to reset 0, cause yeah. Otherwise, I'll do this. This is a pretty brute force. Okay, I'll just do this, and then I need to do I feel like there's another thing I'm trying to do here. If I plus 1 less than length of list, and yeah. Okay. Yeah, I'm just trying to make sure the pointer only goes to these two. And that checks if s of what? The current one and the next one is a 0. Then find next one or place pointer to end of list. If you are a 1, break. That's where we are. Swap. No. I want to do j minus 1 because like we detect one here, right? This is gonna swap with this one right here. Yeah. So j minus 1, j minus 1. Yeah. J minus 1. Swap the element before j. Yeah. Okay. Let's try, I guess. Oh no, we might have gone an infinite while loop. GG's, boys. No, why does that happen though? Where is the infinite while loop? So I plus 1 less than length of this, and the s of I equals 1, and the one next to it is a 0. Start at I. Find the next one. Oh no. Maybe it's this one. We can perform the following operations. Oh, it might be this. I feel like I'm missing something here. Also, wait, hold on. I'm supposed to return an integer. What's happening here, bro? Why is it an infinite while loop? Okay, let me rethink my logic here. Instead of, well, for if I just count, I'm gonna just count the number of blocking ones. So like, so basically count how many ones there are, right? See, ones, that, ones plus, right? So if s of I equals 0, else GG's here, and then we'll just do I plus 1 here. Right, so we can just count the ones. C and T. So count the ones, and the ones that are basically like while I is less than length of S and S of I plus 1. Actually, I want to say like I want to say if it's equal to 1, right? So if it's a 0, 1, then that's what we want to count as well. Just increase, right? And then count is all the ones at that point. How about that? Close. So like, okay, we want to count all, we want to keep moving if so like this is this that? No, that's a 1, so that's plus 1. Then check here, this is a 0, so while that I plus 1 is less than that, if the neighbor of what I'm on right now is a 1, no, if it's a 0, if it's a 0, then skip it. Okay, and then I go here, the neighbor's a 1. No, it stops, so we, yeah, basically I want to count the consecutive zeros, because those are how many ones I can basically be. It's kind of greedy here. Yeah, all right, I'll see you guys tomorrow.